So this is question 14, paper 1, 2012 higher maths, and we're given an integral of something to the power half. And just a little reminder of some facts about integrating. If we integrate the power of x, we increase the power and then divide by the new index. And remember that integrating can always be undone by differentiating. So if we were to take this power of x divided by that number plus a constant and differentiate that, then remember the rule goes we bring this power down, which would then cancel with this, multiply, so that gets cancelled and we take 1 off the power. And of course differentiating a constant number is 0, so we're back to our x to the power n. So we can always check back about differentiating, and in an example like this we can always check back to see if we've achieved what we're supposed to achieve. Now this basic rule, I mean that's not an x, it's a 2x minus 1, but had it been the integral of x to the half, then we would have increased this by 1, adding 2 halves to 1 half to get 3 halves, divide by the new power, and then add c. And of course differentiating back, multiply by 3 over 2, which cancels with that 3 over 2, and take 1 away, which would end you back up at the half, and the c disappears. So we differentiate back to check this out. So we could check whether this works by differentiating back. See, what I've done there is said, well, okay, it's not an x to the power of half. If it had been an x to the power of half, we'd have increased that half by 1 to 3 halves and divided by the 3 halves and added a constant. Now, to check back, we would then differentiate this 2x minus 1, which is in there, to the power 3 over 2, divided by the 3 over 2, constant will just disappear. So if we differentiated this, the 3 over 2 appears at the front, which then cancels with the 3 over 2, leaving you 2x minus 1 to the 1 less than this 3 halves. Take 2 halves away, you get 1 half. But because that's not an x, differentiating, there's the chain rule, and we have to then multiply by whatever we get when we differentiate 2x minus 1, which is a 2. Now, that 2's not there. So we have to get rid of that 2 by dividing by the 2. So that if you think about it, what goes on now, we multiply by the 3 over 2, that cancels. 2x minus 1 to the 1 half, when we take 1 away from this, times 2, which cancels with this 2. And there isn't a 2 there. So this bit here is compensating for the backwards chain rule. When we do the chain rule by differentiating this, we get an extra times 2 appearing, which has to cancel with that. Anyway, there it is. You can just remember that if you have something like an integral of some number times x plus another number to n, then increase the power by 1, divide by the new power, and because it's ax plus b, we have to divide by that a, so it appears in the bottom line. So there's a formula for what you've just been doing, but it's nice to try and understand why you actually get that answer. And it's good to check back to see that everything is working okay. I haven't tidied this up. The 2 times 3 over 2, the 2's cancelled just to leave me a 3, so I'll get 2x minus 1 to the 3 over 2 divided by 3. Now remember that dividing something by 3 is the same as a third. You divide something by 3, you're finding a third of it. So it's basically a third of 2x minus 1 to the power 3 over 2 plus your constant. Now we should have a look and see what the choices are, if you can see them. Can we see this? That? No, there it is. So it's a third of 2x minus 1 to the 3 over 2 plus the constant c, and that's choice A. So choice A.